Question 1. Process analysis reveals that a vSphere administrator is responsible for deploying a large number of new virtual machines to support a critical business application. The primary objective is to ensure that all deployed virtual machines are configured identically, meet stringent security hardening standards, and can be provisioned rapidly to meet business demands. The administrator is evaluating different methods for achieving this. Option A. Manually clone existing virtual machines that are believed to be correctly configured, without a formal process for verification or standardization. Option B. Deploy virtual machines directly from operating system ISOs and manually configure each one after installation, focusing solely on getting the application running quickly. Option C. Utilize vSphere templates and deploy virtual machines from these standardized templates, incorporating post-deployment automation for configuration management and security patching. Option D. Prioritize rapid deployment by skipping detailed security configurations and compliance checks during the initial provisioning phase, planning to address them later. The correct answer is C. Utilize vSphere templates and deploy virtual machines from these standardized templates, incorporating post-deployment automation for configuration management and security patching. Explanation. Scenario analysis. A vSphere administrator is tasked with implementing a new virtual machine deployment strategy. The challenge lies in balancing the need for rapid provisioning with the inherent risks of inconsistent configurations and potential security vulnerabilities that can arise from ad hoc or poorly documented processes. Ensuring compliance with organizational policies and industry best practices for virtual infrastructure management is paramount, especially in a regulated environment where audit trails and standardized deployments are critical. Correct approach analysis. The correct approach involves establishing a standardized, automated deployment process using vSphere features like templates and vRealize automation, or equivalent automation tools available in vSphere 6. This aligns with best practices for infrastructure as code and ensures that every deployed virtual machine adheres to predefined security baselines, configuration standards, and compliance requirements. Automation reduces human error, improves consistency, and provides a verifiable audit trail, which is essential for regulatory compliance and operational efficiency. This approach directly supports the principles of secure and reliable virtual infrastructure management as expected in a professional IT environment. Incorrect approach is analysis. An approach that relies solely on manual cloning of existing virtual machines without a defined template or automation process introduces significant risks. This can lead to configuration drift, security misconfigurations, e.g., default passwords, unpatched software, and a lack of standardization, making auditing and troubleshooting difficult. This violates the principle of controlled and repeatable deployments, potentially leading to non-compliance with security policies and industry standards. Another incorrect approach might be to deploy virtual machines directly from ISOs without any post-installation configuration automation or standardization. This results in highly variable configurations, increased manual effort for security hardening and patching, and a higher likelihood of introducing vulnerabilities. It fails to leverage the capabilities of vSphere for efficient and secure deployment, increasing operational overhead and risk. A third incorrect approach could be to prioritize speed of deployment above all else, neglecting essential security configurations and compliance checks. This is a direct contravention of professional IT security and governance principles. In any regulated environment, such an approach would be considered negligent and could lead to severe security breaches and regulatory penalties. Professional reasoning. Professionals should adopt a decision-making process that prioritizes standardization, automation, and security from the outset. This involves understanding the organization's compliance requirements, defining clear deployment blueprints, templates, and leveraging automation tools to enforce these blueprints consistently. Regular review and updates to these deployment processes are also crucial to adapt to evolving threats and regulatory landscapes. The goal is to create a robust, repeatable, and secure deployment pipeline. Question 2. The assessment process reveals that a vSphere 6 environment has inconsistent virtual network configurations across several EXE hosts, leading to intermittent connectivity issues for critical virtual machines. The IT team needs to standardize these configurations to ensure reliable network access and enhance security. Which of the following methods is the most appropriate for achieving this standardization? Option A. Utilize vSphere distributed switches to define and manage network configurations centrally, ensuring consistency across all hosts added to the distributed switch. Option B. Develop and deploy custom scripts to modify network settings on each host without leveraging vSphere's native management features. Option C. Manually configure the virtual switches and port groups on each XC host individually using the vSphere client. Option D. Rely on existing physical network switch configurations to dictate the virtual network setup on each XC host. The correct answer is A. Utilize vSphere distributed switches to define and manage network configurations centrally, ensuring consistency across all hosts added to the distributed switch. Explanation. The assessment process reveals a common implementation challenge in vSphere environments, ensuring consistent and secure network configurations across multiple hosts. This scenario is professionally challenging because a misconfiguration can lead to network outages, security vulnerabilities, and compliance issues, impacting business operations and data integrity. Careful judgment is required to select the most appropriate method for managing these configurations, balancing efficiency with security and adherence to best practices. The correct approach represents best professional practice because it leverages vSphere's built-in capabilities for centralized management and automation, which are designed to enforce consistency and reduce the risk of human error. This aligns with the principle of least privilege and the need for auditable, repeatable deployments, crucial for maintaining a secure and compliant infrastructure. An incorrect approach that involves manual configuration of each host's virtual switches and port groups is professionally unacceptable. This method is prone to errors, time-consuming, and lacks a centralized audit trail, increasing the risk of security breaches and non-compliance with internal policies or external regulations that mandate secure network segmentation and access controls. Another incorrect approach, relying solely on third-party scripts without proper integration or validation within the vSphere framework, poses significant risks. While scripts can automate tasks, their use without understanding the underlying vSphere networking model or without proper version control and testing can lead to unexpected behavior, instability, and security vulnerabilities. This bypasses the inherent controls and reporting mechanisms provided by vSphere, making troubleshooting and auditing difficult. A further incorrect approach, neglecting to document the network configuration changes, is a critical failure. Lack of documentation hinders troubleshooting, makes it difficult to onboard new team members, and prevents effective auditing for compliance purposes. This directly violates professional standards that require clear and accurate record-keeping for all system changes. The professional reasoning process for similar situations should involve a thorough understanding of the vSphere networking components, the specific requirements of the environment, and the available management tools. Prioritize solutions that offer centralized control, automation, and auditability. Always consider the security implications of any configuration change and ensure it aligns with established security policies and regulatory requirements. Document all changes meticulously and test thoroughly before deploying to production. Question 3. Market research demonstrates that a growing number of organizations are adopting hybrid cloud strategies, necessitating robust and reliable infrastructure upgrades. A vSphere 6X environment is scheduled for a significant upgrade to the underlying host hardware and vSphere version. The primary concern is to minimize downtime and prevent any data corruption or loss for critical virtual machines during this transition. The IT administrator must select the most appropriate strategy for performing this upgrade. Option A. Implement the hardware and vSphere version upgrade without taking any backups or snapshots of the virtual machines. Option B. Conduct a direct, in-place upgrade of all vSphere hosts simultaneously without prior testing or a defined rollback plan. Option C. Perform a phased migration of virtual machines to newly provisioned hosts running the upgraded vSphere version, followed by decommissioning of the old hosts. Option D. Execute an in-place upgrade of the existing vSphere hosts to the new version, and then replace the hardware components one by one. The correct answer is C. Perform a phased migration of virtual machines to newly provisioned hosts running the upgraded vSphere version, followed by decommissioning of the old hosts. Explanation. This scenario presents a common implementation challenge in virtualized environments, ensuring data integrity and availability during a critical infrastructure upgrade. The professional challenge lies in balancing the need for rapid deployment of new technology with the imperative to protect sensitive customer data and maintain service continuity, all while adhering to established best practices and potential regulatory considerations for data handling and system uptime. Careful judgment is required to select a method that minimizes risk and maximizes efficiency. The correct approach represents best professional practice because it prioritizes a phased, controlled rollout that allows for thorough validation at each stage. This minimizes the risk of widespread disruption and data corruption. By performing a pilot deployment, testing thoroughly, and then proceeding with a staged migration, the administrator can identify and rectify any unforeseen issues before they impact the entire production environment. This methodical approach aligns with principles of risk management and operational resilience, which are implicitly expected in professional IT operations, even without explicit regulatory mandates for this specific technology. It ensures that the integrity and availability of virtual machines and their data are maintained throughout the upgrade process. An incorrect approach that involves a direct, in-place upgrade of all hosts simultaneously without prior testing or rollback planning is professionally unacceptable. This method carries an extremely high risk of widespread failure, data loss, and extended downtime. Such a failure could lead to significant business impact for the organization and its clients, potentially violating service-level agreements and damaging the company's reputation. While no specific vSphere 6 regulation is being violated, this approach demonstrates a severe lack of due diligence and adherence to fundamental IT operational best practices, which are the bedrock of professional conduct. Another incorrect approach, performing the upgrade without any form of backup or snapshot strategy, is equally egregious. Data loss is a direct and severe consequence of such negligence. In many industries, data protection and recovery are subject to stringent regulations. Even in the absence of explicit regulations for this particular scenario, the failure to implement basic data protection measures constitutes a gross dereliction of professional duty and could have severe legal and financial repercussions if data is lost. A third incorrect approach, relying solely on vendor documentation without internal validation or testing, is also professionally deficient. While vendor documentation is a valuable resource, it cannot account for the unique configurations and specific operational nuances of every environment. Skipping internal testing and validation leaves the administrator vulnerable to environment-specific issues that the vendor documentation may not cover, leading to unexpected failures and potential data integrity problems. This demonstrates a failure to exercise independent professional judgment and due diligence. The professional reasoning process for similar situations should involve a comprehensive risk assessment, followed by the development of a detailed implementation plan. This plan should include clear objectives, rollback strategies, testing procedures, and communication protocols. Prioritizing data integrity and service availability, and selecting methods that demonstrably mitigate risks are paramount. Professionals must always consider the potential impact of their actions on the business and its stakeholders, and act with prudence and foresight. Question 4. Risk assessment procedures indicate that a critical vSphere 6X upgrade is scheduled for the production environment. The upgrade aims to introduce new security patches and performance enhancements. However, the current operational tempo and resource constraints have led to a proposal to bypass extensive pre-production testing and the development of a formal rollback plan to expedite the deployment. What is the most professionally responsible approach to managing this upgrade? Option A. Conduct thorough testing in a lab environment that closely mirrors the production network and hardware, and develop a comprehensive, tested rollback plan before proceeding with any production deployment. Option B. Perform the upgrade on all production hosts, but rely on manual intervention and ad hoc troubleshooting to address any issues that may arise during or after the deployment. Option C. Implement the upgrade on a select group of production hosts to gauge impact, but defer the creation of a formal rollback plan until after the initial deployment. Option D. Proceed with the upgrade on all production hosts simultaneously, prioritizing speed over comprehensive testing and rollback planning. The correct answer is D. Proceed with the upgrade on all production hosts simultaneously, prioritizing speed over comprehensive testing and rollback planning. Explanation. Scenario analysis. This scenario presents a common implementation challenge in virtualized environments, ensuring data integrity and availability during a critical upgrade. The professional challenge lies in balancing the need for rapid deployment of new features and security patches with the inherent risks of disrupting production workloads. The pressure to meet deadlines, coupled with the potential for significant business impact if the upgrade fails, requires careful planning, risk mitigation, and adherence to established best practices. The absence of a rollback plan introduces a significant point of failure, making the decision-making process particularly sensitive. Correct approach analysis. The correct approach involves a phased rollout with comprehensive testing and a documented rollback strategy. This represents best professional practice because it systematically reduces risk at each stage. Implementing changes in a non-production environment first allows for validation of functionality and performance without impacting live services. Subsequent testing in a staging environment, mirroring production as closely as possible, further refines the process. The inclusion of a detailed rollback plan is crucial for business continuity. In the event of unforeseen issues, a swift and controlled return to the previous stable state minimizes downtime and data loss, thereby upholding the organization's service-level agreements and maintaining customer trust. This aligns with general IT governance principles of change management and risk management, which are implicitly expected in professional IT operations. Incorrect approaches analysis. Implementing the upgrade directly on all production hosts without prior testing or a rollback plan is a direct violation of prudent change management practices. This approach introduces an unacceptable level of risk, potentially leading to widespread service disruption, data corruption, and significant financial losses. It demonstrates a failure to adequately assess and mitigate risks, which is a fundamental professional failing. Performing the upgrade on a subset of production hosts, but without a documented rollback strategy, is also professionally unacceptable. While it introduces a limited scope of risk compared to a full rollout, the absence of a rollback plan means that if issues arise on the tested subset, organization is still exposed to significant disruption and potential data loss. This approach fails to provide a safety net for critical operations. Conducting extensive testing in a lab environment that does not accurately reflect the production network configuration and hardware specifications is insufficient. While testing is performed, its lack of relevance to the actual production environment means that issues specific to the production setup may go undetected. This leads to a false sense of security and increases the likelihood of encountering unexpected problems during the actual deployment without a plan to recover. Professional reasoning. Professionals should approach such implementation challenges by first conducting a thorough risk assessment. This involves identifying potential failure points, their impact, and the likelihood of occurrence. Based on this assessment, a phased implementation plan should be developed, prioritizing testing in non-production and staging environments. A critical component of this plan is the creation of a detailed and tested rollback strategy. This strategy should outline the exact steps required to revert to the previous stable state, including any necessary data restoration procedures. Communication with stakeholders regarding the plan changes and potential risks is also paramount. The decision-making process should always prioritize the stability and integrity of production systems and the continuity of business operations. Question 5. Operational review demonstrates that a vSphere 6.0 host within a cluster has unexpectedly failed, causing all virtual machines running on that host to become unavailable. The cluster is configured with vSphere high availability. What is the most appropriate immediate action to restore virtual machine availability? Option A. Allow vSphere high availability to automatically restart the virtual machines on other available hosts. Option B. Manually migrate the virtual machines from the failed host to other hosts in the cluster. Option C. Initiate a manual restart of the virtual machines on other available hosts after the failed host is removed. Option D. Power off all virtual machines on the failed host and wait for the host to be replaced before powering them back on. The correct answer is B. Manually migrate the virtual machines from the failed host to other hosts in the cluster. Explanation. This scenario presents a common implementation challenge in virtualized environments, ensuring consistent and reliable network connectivity for virtual machines, VM, after a host hardware failure. The professional challenge lies in quickly restoring service while adhering to best practices for vSphere 6.0, which emphasizes stability, performance, and security. The need to minimize downtime and data loss requires a swift yet methodical approach. The correct approach involves leveraging vSphere's high availability feature. vSphere HA automatically restarts VMs on other available hosts in the cluster when a host fails. This is the best professional practice because it is a built-in, automated mechanism designed specifically for this purpose, minimizing manual intervention and reducing the window of service disruption. It aligns with the principle of ensuring business continuity and service availability, which are core tenets of IT operations and implicitly supported by the operational guidelines for managing virtualized infrastructure. An incorrect approach would be to manually migrate VMs from the failed host to other hosts. This is professionally unacceptable because it is time-consuming, prone to human error, and significantly increases the risk of extended downtime. It bypasses the automated resilience mechanisms provided by vSphere HA, demonstrating a lack of understanding or adherence to the platform's intended operational model. Furthermore, it could lead to performance degradation on the destination hosts if not carefully managed, potentially violating service-level agreements. Another incorrect approach would be to power off all VMs on the failed host and then manually power them back on after the host is replaced. This is professionally unsound as it introduces unnecessary downtime and data loss if VMs are not cleanly shut down. It also ignores the immediate availability of other hosts within the cluster that could host the VMs. This approach fails to utilize the cluster's inherent redundancy and resilience capabilities, indicating a significant lapse in operational judgment and a disregard for efficient resource utilization and service continuity. The professional decision-making process for such situations should involve 1. Understanding the immediate impact. Assess the scope of the failure and the services affected. 2. Recalling and applying platform capabilities. Identify and utilize the built-in features designed for resilience, such as vSphere HA. 3. Prioritizing automation and efficiency. Favor automated solutions over manual interventions to minimize risk and downtime. 4. Considering service-level objectives. Ensure the chosen approach meets or exceeds the required uptime and performance standards. 5. Documenting the incident and resolution. Learn from the event and update operational procedures as necessary. Question 6. Quality control measures reveal an unexpected deviation in vSphere 6 performance metrics for a critical virtual machine cluster, which is not currently impacting operational availability, but suggests a potential underlying issue with data collection or resource allocation. What is the most appropriate immediate course of action? Option A. Ignore the anomaly as it is not currently causing any operational downtime or performance degradation for end users. Option B. Document the anomaly in detail, initiate a formal investigation into the root cause, and report the findings through the established change management and incident reporting channels. Option C. Immediately attempt to correct the performance metric deviation by adjusting virtual machine configurations without further investigation or documentation. Option D. Inform management of the anomaly with preliminary observations, but without a thorough investigation or proposed resolution. The correct answer is B. Document the anomaly in detail, initiate a formal investigation into the root cause, and report the findings through the established change management and incident reporting channels. Explanation. This scenario presents a professional challenge due to the potential for data integrity compromise and the ethical obligation to report findings accurately. The core issue revolves around the discovery of an anomaly that could impact the reliability of vSphere 6 performance metrics, which are crucial for operational decisions, capacity planning, and potentially for compliance reporting. The professional must navigate the tension between immediate remediation and thorough investigation, while adhering to established protocols and ethical standards. The correct approach represents best professional practice because it prioritizes transparency, accuracy, and adherence to established procedures. By documenting the anomaly, initiating a formal investigation, and communicating findings through appropriate channels, the professional upholds the integrity of the data and the vSphere environment. This aligns with general IT best practices and ethical guidelines that emphasize honesty, diligence, and accountability in reporting technical findings. While the 2V0-620 exam focuses on technical foundations, the underlying principles of professional conduct are implicitly expected. An incorrect approach that involves immediately correcting the anomaly without proper documentation or investigation fails to establish a clear root cause and could mask underlying issues. This bypasses established quality control and incident management processes, potentially leading to recurring problems or an incomplete understanding of the system's behavior. It also risks introducing new errors during an undocumented fix. Another incorrect approach, which is to ignore the anomaly because it does not appear to be causing immediate operational disruption, is professionally negligent. This demonstrates a lack of diligence and a failure to proactively identify and address potential risks. Ignoring anomalies can lead to unforeseen consequences down the line, impacting system stability, performance, or security, and violates the professional duty to maintain a robust and reliable IT infrastructure. A further incorrect approach, which is to report the anomaly without sufficient investigation or context, could lead to unnecessary alarm or misallocation of resources. While transparency is important, premature or incomplete reporting can be counterproductive and erode confidence in the reporting process. The professional decision-making process in such situations should involve a systematic approach. First, observe and document the anomaly thoroughly. Second, assess the potential impact, even if not immediately apparent. Third, consult relevant documentation and establish troubleshooting procedures. Fourth, initiate a formal investigation process involving appropriate stakeholders if necessary. Finally, communicate findings and proposed actions through official channels, ensuring accuracy and completeness. Question 7. The control framework reveals a situation where a third-party vendor requires elevated access to the vSphere 6 environment to perform a critical update. The vendor has requested full administrative privileges for an indefinite period to ensure they can complete their work without interruption. As the vSphere administrator, you are concerned about the security implications of granting such broad and prolonged access. What is the most professional and secure course of action? Option A. Grant the vendor full administrative privileges immediately and indefinitely, as their request is for a critical update and their expertise is trusted. Option B. Grant the vendor temporary administrative privileges for a clearly defined period, ensuring all actions are logged and requiring explicit authorization from your management before proceeding. Option C. Deny the vendor any access to the vSphere environment, instructing them to resolve the update issue remotely without direct system interaction. Option D. Grant the vendor temporary administrative privileges but do not implement any logging or monitoring, as this might be perceived as a lack of trust and could slow down their work. The correct answer is B. Grant the vendor temporary administrative privileges for a clearly defined period, ensuring all actions are logged and requiring explicit authorization from your management before proceeding. Explanation. This scenario presents a professional challenge due to the inherent conflict between a vendor's request for privileged access and the IT administrator's responsibility to maintain system security and data integrity. The administrator must balance the need for vendor support with the imperative to protect the vSphere environment from unauthorized access or potential misuse. The core of the challenge lies in upholding the principle of least privilege and ensuring that any access granted is strictly necessary, time-bound, and auditable. The correct approach represents best professional practice because it prioritizes security and compliance. By documenting the request, assessing its necessity, obtaining explicit authorization, and ensuring the access is temporary and logged, the administrator adheres to fundamental security principles. This aligns with the general ethical obligations of IT professionals to safeguard systems and data, as often reinforced by organizational policies and industry best practices, even if not explicitly codified in a specific, universally applicable vSphere 6 Foundations exam regulation beyond general IT security tenets. The emphasis on a documented, authorized, and time-limited access window minimizes risk and provides an audit trail, crucial for accountability. An incorrect approach involving granting immediate, broad access without proper authorization or documentation fails to uphold the principle of least privilege. This creates a significant security vulnerability, as the vendor could potentially access sensitive data or make unauthorized changes. Such an action would likely violate organizational security policies and could be considered a breach of professional ethics by exposing the environment to undue risk. Another incorrect approach, refusing all access without exploring a secure, controlled method, might hinder necessary vendor support and potentially violate service-level agreements or contractual obligations. While security is paramount, an outright refusal without attempting to find a secure solution can be professionally detrimental and may not be the most effective way to manage the situation. A third incorrect approach, granting access but failing to log or monitor it, is equally problematic. Even with authorization, the lack of auditing means there is no way to verify the vendor's actions or to investigate any potential security incidents. This omission undermines accountability and makes it impossible to identify and rectify any unauthorized activities, representing a failure in due diligence and professional responsibility. The professional decision-making process for similar situations should involve a structured risk assessment. First, understand the request and its purpose. Second, evaluate the necessity and potential impact of granting the requested access. Third, consult relevant policies and seek appropriate authorization. Fourth, implement the access in the most secure and least privileged manner possible, with strict time limitations and comprehensive logging. Finally, verify that the access has been revoked and the logs have been reviewed. Question 8. The control framework reveals a situation where a third-party vendor requires temporary administrative access to a vSphere 6 environment to troubleshoot a critical performance issue. The vendor's representative has requested direct root access to the vCenter server for an extended period to diagnose the problem. What is the most appropriate course of action for the vSphere administrator? Option A. Provide the vendor with a read-only account to the vCenter server, which should be sufficient for them to gather the necessary information. Option B. Escalate the request to the internal security team, document the vendor's request and proposed access, and seek explicit authorization for a limited scoped access session. Option C. Deny the vendor any access and instruct them to provide detailed logs and error reports for internal analysis. Option D. Grant the vendor direct root access to the vCenter server, as their request is for troubleshooting a critical issue and they are a trusted partner. The correct answer is D. Grant the vendor direct root access to the vCenter server, as their request is for troubleshooting a critical issue and they are a trusted partner. Explanation. This scenario presents a professional challenge due to the inherent conflict between a vendor's request for privileged access and the organization's responsibility to maintain the security and integrity of its vSphere environment. The core of the challenge lies in balancing the need for vendor support with the imperative to protect sensitive data and system configurations from unauthorized access or potential misuse. Careful judgment is required to ensure that any access granted is strictly controlled, necessary, and documented, adhering to established security policies and ethical standards. The correct approach represents best professional practice because it prioritizes security and compliance by seeking explicit authorization and defining the scope of access. This aligns with the principles of least privilege and accountability, which are fundamental to robust IT security frameworks. By involving the security team and documenting the request and approval, the administrator ensures that the access is not granted arbitrarily, thereby mitigating risks of unauthorized actions or data breaches. This proactive stance demonstrates a commitment to upholding organizational policies and safeguarding the vSphere environment. An incorrect approach that involves granting immediate access without proper authorization or documentation is professionally unacceptable. This action directly violates security policies that mandate approval for privileged access and creates a significant security vulnerability. It bypasses established control mechanisms, making it impossible to track who accessed what and when, thus hindering any potential forensic investigation. This failure to adhere to established procedures constitutes a breach of professional responsibility and could lead to severe security incidents, data loss, or compliance violations. Another incorrect approach, which is to refuse access entirely without exploring alternatives or understanding the necessity of the vendor's request, might also be professionally suboptimal. While security is paramount, an outright refusal without consultation could impede critical support operations, potentially leading to system downtime or unresolved issues that impact business continuity. This approach lacks the nuanced judgment required to balance security needs with operational requirements. A more professional response would involve engaging with the vendor and the internal security team to find a secure and compliant method for providing necessary access. A professional decision-making process for similar situations should involve a clear understanding of organizational security policies and procedures. When faced with a request for privileged access, an IT professional should 1. Understand the nature and necessity of the request. 2. Consult relevant internal policies regarding vendor access and data security. 3. Engage the appropriate internal stakeholders, such as the security team or management, for review and authorization. 4. If approved, ensure that access is granted with the minimum necessary privileges and for a defined limited duration. 5. Document all requests, approvals, and access granted. 6. Verify that the vendor adheres to the agreed-upon terms and revoke access promptly upon completion of the task. Question 9. Compliance review shows that several critical business applications hosted on vSphere 6 are experiencing intermittent performance degradation, impacting user productivity. The infrastructure team is under pressure to resolve this quickly. Which of the following approaches best aligns with process optimization principles and ensures a stable, compliant vSphere environment? Option A. Conduct a thorough performance analysis using vSphere monitoring tools to identify resource bottlenecks, and then implement a targeted remediation plan following change management procedures. Option B. Randomly migrate virtual machines hosting critical applications to different XC hosts in the cluster without prior analysis or planning. Option C. Immediately increase the allocated CPU and memory resources for all virtual machines running critical applications, assuming a general resource shortage. Option D. Disable non-essential services on the virtual machines experiencing performance issues to free up resources, without assessing their dependencies. Correct answer is A. Conduct a thorough performance analysis using vSphere monitoring tools to identify resource bottlenecks, and then implement a targeted remediation plan following change management procedures. Explanation. Scenario analysis. This scenario presents a common challenge in IT operations where performance bottlenecks are impacting critical business functions. The professional is tasked with identifying and resolving these issues within the constraints of a production vSphere environment. The challenge lies in balancing the need for immediate resolution with the potential risks of disruptive troubleshooting, all while adhering to established operational procedures and potentially regulatory compliance requirements related to service availability and data integrity. The pressure to restore service quickly can lead to hasty decisions that might overlook root causes or introduce new problems. Correct approach analysis. The correct approach involves a systematic, data-driven investigation to pinpoint the root cause of the performance degradation. This aligns with best practices for IT service management and process optimization, emphasizing proactive monitoring, root cause analysis, and controlled remediation. In a vSphere environment, this means leveraging the built-in performance monitoring tools like vCenter Performance Charts, ESCSTOP, vRealize Operations if available, to gather metrics on CPU, memory, storage I/O, and network utilization across the affected virtual machines and underlying infrastructure. Identifying patterns and correlating events is crucial. Once the root cause is identified, e.g., a specific VM consuming excessive resources, a storage array experiencing high latency, or a network congestion point, a plan change can be implemented. This plan change should follow a defined change management process, including impact assessment, rollback procedures, and scheduled maintenance windows where possible, to minimize disruption. This methodical approach ensures that the fix addresses the actual problem, prevents recurrence, and maintains the stability and availability of the vSphere environment, which is often a requirement for business continuity and regulatory compliance. Incorrect approach is analysis. Implementing a broad, unverified resource increase across all virtual machines without identifying the specific cause is a failure of process optimization and potentially regulatory compliance. This approach is akin to treating symptoms rather than the disease. It is inefficient, costly, and risks exacerbating performance issues by overloading already strained resources or masking the true bottleneck. From a regulatory perspective, such a reactive and unscientific approach could be seen as a failure to maintain a stable and reliable IT environment, potentially impacting service-level agreements, SLAs, and business continuity plans, which are often subject to audit and compliance. Randomly migrating virtual machines to different hosts without a clear understanding of resource contention or host capabilities is also a failure of process optimization. This action is disruptive, can lead to further performance degradation if the target hosts are also experiencing issues, and does not address the underlying problem. It represents a lack of systematic troubleshooting and can violate change management policies, leading to an unstable environment and potential compliance breaches related to IT governance and risk management. Disabling non-critical services on affected virtual machines without understanding their dependencies or impact on business operations is a risky and unscientific approach. While it might temporarily free up resources, it can break critical business functionality, leading to service outages and potential data loss. This reactive measure bypasses proper impact assessment and change control, which are fundamental to maintaining a compliant and reliable IT infrastructure. It demonstrates a disregard for the interconnectedness of systems and the potential for unintended consequences, which can have significant regulatory and business implications. Professional reasoning. Professionals should approach performance degradation by first establishing a baseline of normal operation. When issues arise, they must engage in systematic data collection and analysis using available tools. The process optimization principle dictates that solutions should be targeted, data-backed, and implemented through a controlled change management framework. This ensures that the resolution is effective, efficient, and minimizes risk to the production environment and its compliance posture. When faced with performance issues, a professional decision-making process involves 1. Monitoring and alerting. Ensure robust monitoring is in place. 2. Data gathering. Collect relevant performance metrics. 3. Root cause analysis. Analyze data to identify the underlying issue. 4. Solution design. Develop a targeted and tested solution. 5. Change management. Plan and execute the change with proper approvals and rollback. 6. Verification. Confirm the issue is resolved and monitor for recurrence. Question 10. Risk assessment procedures indicate that the current process for deploying new virtual machines in the vSphere 6 environment is time-consuming and prone to configuration errors, potentially impacting service delivery. Which of the following approaches would best optimize this process while maintaining operational integrity and minimizing risk? Option A. Implement automated VM deployment scripts without any resource pre-allocation checks or configuration validation. Option B. Prioritize reducing the time for individual VM deployment above all other considerations, including resource allocation and security hardening. Option C. Enable all administrators to create virtual machines on demand, bypassing any standardized procedures to expedite deployment. Option D. Develop and utilize standardized VM templates with predefined configurations, and implement a formal change control process for all VM deployments. The correct answer is D. Develop and utilize standardized VM templates with predefined configurations, and implement a formal change control process for all VM deployments. Explanation. Scenario analysis. The scenario presents a common challenge in IT operations, balancing the need for rapid deployment of new virtual machines with the inherent risks of insufficient resource allocation. The professional is tasked with optimizing the process of VM provisioning. The challenge lies in identifying the most effective method to streamline this process without compromising the stability and performance of the vSphere environment, which could lead to service disruptions and potential compliance issues if service-level agreements, SLAs, are not met. Correct approach analysis. Implementing a standardized VM template with pre-configured settings and a robust change control process represents best professional practice. This approach directly addresses process optimization by reducing manual configuration steps, ensuring consistency, and minimizing errors. From a regulatory and ethical standpoint, it promotes predictability and reliability in service delivery, aligning with the implicit requirement to maintain operational integrity and meet service commitments. The change control process ensures that any deviations or additions are documented and approved, providing an audit trail and mitigating unauthorized changes that could impact security or performance. Incorrect approaches analysis. Allowing individual administrators to create VMs ad hoc without templates or standardized configurations introduces significant risk. This approach leads to inconsistencies, potential security vulnerabilities due to unpatched or misconfigured systems, and makes troubleshooting difficult. It violates the principle of controlled change and can lead to performance degradation, impacting SLAs and potentially breaching contractual obligations. Automating VM deployment without any form of validation or resource pre-allocation is also professionally unacceptable. While automation is a key aspect of process optimization, Unchecked automation can lead to resource exhaustion, impacting the performance of existing VMs and the hypervisor itself. This can result in service outages, directly contravening the duty to provide reliable services and potentially violating regulatory requirements related to service availability. Focusing solely on reducing the time taken to deploy a VM without considering resource allocation or configuration standards is a superficial optimization. This approach prioritizes speed over stability and security, can lead to the deployment of under-resourced or insecure VMs, which can cause performance issues, security breaches, and increased operational overhead for remediation, ultimately undermining the overall efficiency and reliability of the vSphere environment. Professional reasoning. Professionals should approach process optimization by first understanding the current state, identifying bottlenecks, and then implementing solutions that address both efficiency and risk. A structured approach involving standardization, automation with validation, and robust change management is crucial. This ensures that optimizations contribute to overall system health and meet operational and any applicable regulatory requirements. Question 11. Assessment of process optimization strategies for a vSphere 6 environment requires a methodical approach to identify and resolve performance bottlenecks. Which of the following strategies best exemplifies a professional and effective method for optimizing resource utilization in a virtualized infrastructure? Option A. Focus solely on reducing the number of virtual machines running in the environment without analyzing their actual resource consumption or business criticality. Option B. Conduct a comprehensive performance analysis of the vSphere environment to identify underutilized resources and areas of contention. Then implement targeted adjustments to virtual machine configurations and resource allocation based on this data. Option C. Immediately upgrade all physical server hardware and increase the allocated resources for all virtual machines to preemptively address any potential performance issues. Option D. Implement widespread, unvalidated configuration changes across a broad range of virtual machines simultaneously to observe any potential performance improvements. The correct answer is B. Conduct a comprehensive performance analysis of the vSphere environment to identify underutilized resources and areas of contention. Then implement targeted adjustments to virtual machine configuration and resource allocation based on this data. Explanation. This scenario presents a common challenge in IT infrastructure management, optimizing resource utilization to improve performance and reduce costs without compromising service availability or introducing new risks. The professional challenge lies in balancing competing demands and understanding the intricate dependencies within a vSphere environment. Careful judgment is required to select the most effective optimization strategy that aligns with operational goals and avoids unintended consequences. The correct approach represents best professional practice because it systematically identifies and addresses performance bottlenecks through a phased, data-driven methodology. This aligns with the principles of efficient resource management and proactive system maintenance, which are implicitly expected in professional IT operations. By focusing on understanding current resource consumption and identifying areas of inefficiency, this method ensures that optimizations are targeted and effective, leading to tangible improvements in performance and cost savings. This approach also minimizes the risk of introducing instability by allowing for controlled testing and validation. An incorrect approach that focuses solely on increasing hardware resources without a thorough analysis of current utilization is professionally unacceptable. This represents a reactive and potentially wasteful strategy that fails to address underlying inefficiencies. It can lead to over-provisioning, increased operational costs, and a failure to achieve optimal performance. From a regulatory or ethical standpoint, this approach could be seen as a failure of due diligence in managing company assets responsibly. Another incorrect approach that involves making broad, unvalidated changes to virtual machine configurations across the environment is also professionally unacceptable. This shotgun method carries a high risk of unintended consequences, such as performance degradation, application failures, or security vulnerabilities. It demonstrates a lack of methodical problem solving and a disregard for the potential impact on critical business operations. Ethically, this approach could be considered negligent, as it exposes the organization to unnecessary risks without proper planning or testing. The professional decision-making process for similar situations should involve a structured approach. 1. Define clear objectives for the optimization effort. 2. Gather comprehensive data on current system performance and resource utilization. 3. Analyze the data to identify specific bottlenecks and areas for improvement. 4. Develop a targeted optimization plan with specific measurable actions. 5. Implement changes in a controlled manner with thorough testing and validation at each stage. 6. Monitor the impact of changes and iterate as necessary. This systematic process ensures that optimizations are effective, efficient, and minimize risk. Question 12. Comparative studies suggest that when introducing new virtualization technologies like vSphere 6, IT professionals often face challenges in integrating them with existing operational frameworks. From a stakeholder perspective, which of the following approaches best balances the need for technological advancement with the imperative of maintaining a secure and compliant operational environment, considering the principles of responsible IT deployment? Option A. Prioritize the technical implementation of vSphere 6 based on vendor recommendations, with minimal consideration for how it aligns with the organization's current security and operational policies. Option B. Deploy vSphere 6 in a limited capacity for testing purposes without formal policy review, deferring policy updates until operational issues arise. Option C. Proceed with the vSphere 6 deployment immediately to leverage its new features, assuming existing policies will implicitly cover the new technology. Option D. Proactively review and update existing change management and security policies to explicitly address the integration and operational requirements of vSphere 6 before deployment. The correct answer is D. Proactively review and update existing change management and security policies to explicitly address the integration and operational requirements of vSphere 6 before deployment. Explanation. The scenario presents a common challenge in IT environments where a new technology, vSphere 6, is being introduced. The professional challenge lies in balancing the desire for innovation and improved performance with the need to adhere to established operational procedures and security policies, particularly when those policies are not explicitly designed for the new technology. The stakeholder perspective is crucial here, as different groups will have varying priorities and concerns. The IT operations team will focus on stability and manageability, while the development team might prioritize rapid deployment and feature access. The core of the professional challenge is navigating these competing interests while ensuring compliance with the overarching regulatory framework governing IT operations, which in the context of the 2V0-620 exam implies adherence to best practices and vendor guidelines for VMware products. The correct approach, which involves thoroughly reviewing and updating existing change management and security policies to accommodate vSphere 6, represents best professional practice because it proactively addresses potential risks and ensures that the new technology is integrated in a controlled and secure manner. This aligns with the principles of responsible IT deployment, emphasizing due diligence and risk mitigation. By updating policies, the organization demonstrates a commitment to maintaining a secure and compliant environment, which is a fundamental ethical and professional obligation. This proactive stance ensures that all stakeholders understand the operational parameters and security controls for vSphere 6, fostering trust and transparency. An incorrect approach that bypasses the established change management process and deploys vSphere 6 without policy review or approval would represent a significant regulatory and ethical failure. This bypass undermines the organization's governance framework, potentially exposing it to security vulnerabilities and operational instability. It disregards the established controls designed to protect organizational assets and data, which is a breach of professional responsibility. Another incorrect approach, focusing solely on the technical capabilities of vSphere 6 without considering its impact on existing infrastructure and security posture, fails to acknowledge the interconnectedness of IT systems and the importance of a holistic security strategy. This narrow focus can lead to unforeseen compatibility issues and security gaps, violating the principle of due care. Finally, an approach that prioritizes speed of deployment over thorough testing and policy alignment demonstrates a disregard for risk management and operational integrity, which are core tenets of professional IT practice. The professional decision-making process for similar situations should involve a structured approach. First, identify all relevant stakeholders and their concerns. Second, Thoroughly understand the new technology and its implications for existing policies and procedures. Third, engage in a collaborative review of policies involving relevant teams to ensure they are updated to reflect the new technology's requirements and risks. Fourth, conduct a comprehensive risk assessment and implement appropriate mitigation strategies. Finally, ensure all changes are documented and approved through the established change management process, thereby maintaining a clear audit trail and demonstrating adherence to best practices and regulatory expectations. Question 13. Cost-benefit analysis shows that decommissioning a legacy vSphere 5 environment and migrating to vSphere 6.0 could result in significant savings on hardware maintenance and support contracts. However, the IT operations team has raised concerns about the potential for compatibility issues with existing applications and the increased complexity of managing a newer version. The compliance department has also indicated that the current vSphere 5 environment has not undergone a recent security audit, and there are no immediate plans for one. Considering these factors, which approach best balances cost savings with operational stability and compliance? Option A. Conduct a thorough compatibility assessment of all critical applications with vSphere 6.0. Perform a comprehensive security audit of the existing vSphere 5 environment and develop a phased migration plan that includes rigorous testing and rollback procedures before decommissioning the old environment. Option B. Outsource the entire migration process to a third-party vendor without internal oversight, assuming they will handle all compatibility and compliance aspects. Option C. Proceed with the migration to vSphere 6.0 immediately to realize the cost savings and address any compatibility or compliance issues as they arise post-migration. Option D. Defer the migration to vSphere 6.0 indefinitely due to the potential for application compatibility issues and the lack of a recent security audit, prioritizing the stability of the current environment. The correct answer is C. Proceed with the migration to vSphere 6.0 immediately to realize the cost savings and address any compatibility or compliance issues as they arise post-migration. Explanation. This scenario presents a common challenge in IT infrastructure management, balancing immediate cost savings with long-term operational risks and compliance. The challenge lies in the inherent tension between the desire to reduce expenditure and the imperative to maintain a secure, stable, and compliant environment. Stakeholders, particularly those focused on budget, may prioritize short-term financial gains, while IT operations and compliance teams must consider the broader implications of technical decisions. The correct approach represents best professional practice because it prioritizes a comprehensive risk assessment and adherence to established security and operational standards. This aligns with the foundational principles of IT governance, which emphasize due diligence, risk mitigation, and the protection of organizational assets and data. By involving relevant stakeholders and ensuring that any proposed changes are evaluated against established policies and potential security vulnerabilities, the organization upholds its responsibility to maintain a robust and compliant infrastructure. This proactive stance minimizes the likelihood of future security breaches, data loss, or regulatory penalties, ultimately safeguarding the organization's reputation and financial stability. An incorrect approach that focuses solely on immediate cost reduction without adequate risk assessment fails to meet professional standards. This is because it disregards the potential for increased security vulnerabilities, operational instability, and non-compliance with relevant regulations. Such an approach can lead to significant unforeseen costs down the line, including incident response, system downtime, data recovery, and potential fines. Another incorrect approach that bypasses established change management procedures is also professionally unacceptable. This is due to the inherent risks associated with unvetted changes, which can introduce unintended consequences, conflicts with existing systems, and security gaps. Furthermore, ignoring the need for proper documentation and testing undermines the principles of accountability and auditability, which are critical for maintaining a secure and manageable IT environment. Professionals should employ a structured decision-making process that begins with clearly defining the problem and its objectives. This should be followed by identifying all relevant stakeholders and their perspectives. A thorough assessment of potential solutions, including their technical feasibility, security implications, operational impact, and cost benefit, is crucial. This assessment must be guided by organizational policies, industry best practices, and any applicable regulatory requirements. The decision-making process should be transparent, documented, and involve a consensus-building approach where possible, ensuring that the chosen path aligns with the organization's overall strategic goals and risk tolerance. Question 14. To address the challenge of a critical business unit requesting immediate deployment of a new application requiring specific, non-standard virtual machine configurations that deviate from current vSphere 6 best practices, what is the most professionally sound approach from a stakeholder perspective? Option A. Implement the requested configurations on a separate, isolated host to avoid impacting the existing production environment without further consultation. Option B. Immediately provision the virtual machines with the requested configurations to meet the business unit's urgent needs, prioritizing their immediate operational requirements. Option C. Initiate a formal change request process to thoroughly assess the business impact, technical feasibility, security implications, and potential conflicts with existing infrastructure before any implementation. Option D. Advise the business unit that their request cannot be accommodated due to existing vSphere 6 best practices, and suggest they adapt their application to the standard configurations. The correct answer is C. Initiate a formal change request process to thoroughly assess the business impact, technical feasibility, security implications, and potential conflicts with existing infrastructure before any implementation. Explanation. The scenario presents a common challenge in IT infrastructure management, balancing the immediate needs of a business unit with the long-term stability and security of the virtualized environment. The stakeholder perspective is critical here, as different departments will have varying priorities and levels of technical understanding. The challenge lies in ensuring that decisions made to satisfy one stakeholder do not negatively impact others or violate established best practices and potential regulatory compliance, even at a foundational level. Careful judgment is required to navigate these competing interests effectively. The correct approach represents best professional practice because it prioritizes a structured, documented, and collaborative process. This aligns with the foundational principles of IT governance and operational excellence, which are implicitly expected even in a foundations exam. By involving all relevant parties, assessing the impact, and adhering to established procedures, the organization minimizes risk, ensures transparency, and promotes a shared understanding of the infrastructure's capabilities and limitations. This proactive and inclusive method is crucial for maintaining a stable and secure vSphere environment. An incorrect approach that bypasses established change control processes and directly implements a request without proper assessment poses significant regulatory and ethical risks. This could lead to unintended consequences such as performance degradation, security vulnerabilities, or incompatibility issues that could impact other business operations. Ethically, it demonstrates a disregard for established procedures and the potential impact on other users of the shared infrastructure. Another incorrect approach that focuses solely on the immediate request without considering broader implications ignores the interconnected nature of a virtualized environment. This can lead to technical debt and future problems that are more costly to resolve. Third incorrect approach that involves making unilateral decisions without consulting relevant stakeholders or documenting the changes is unprofessional and creates an environment of distrust and potential chaos. It undermines the principles of accountability and transparency. Professionals should employ a decision-making framework that begins with understanding the request and its business justification. This should be followed by a thorough impact assessment, considering technical, security, and operational implications. Consultation with relevant stakeholders, including other IT teams and business unit representatives, is essential. Adherence to documented change management procedures, including risk assessment and rollback planning, is paramount. Finally, clear documentation of the decision and any implemented changes ensures accountability and facilitates future reference. Question 15. Operational review demonstrates that while critical applications are adequately protected by vSphere High Availability (HA) and Distributed Resource Scheduler (DRS), several less critical virtual machines are not configured with HA, and backup schedules for these VMs have been reduced to save on storage costs. Additionally, the organization is considering consolidating some of these less critical VMs onto fewer hosts to reduce hardware footprint. What is the most professionally responsible course of action? Option A. Increase the frequency of backups for critical VMs and ignore the configuration of less critical VMs to focus resources on the most important assets. Option B. Disable HA for all non-critical virtual machines and further reduce backup frequency to maximize cost savings. Option C. Consolidate all virtual machines onto the minimum number of hosts possible, regardless of HA or DRS configurations, to achieve maximum hardware efficiency. Option D. Implement a risk-based approach to HA and backup configurations for all virtual machines, ensuring that RPOs and RTOs are met for each, and conduct regular DR testing. The correct answer is D. Implement a risk-based approach to HA and backup configurations for all virtual machines, ensuring that RPOs and RTOs are met for each, and conduct regular DR testing. Explanation. This scenario presents a common challenge in IT infrastructure management, balancing performance needs with resource constraints and the need for robust disaster recovery. Professional challenge lies in understanding the implications of different vSphere configurations on application availability and data integrity, particularly when faced with budget limitations or perceived urgency. Careful judgment is required to avoid making decisions that compromise long-term stability or regulatory compliance for short-term gains. The correct approach prioritizes the integrity and availability of critical business applications, aligning with the foundational principles of IT service management and disaster recovery planning. By ensuring that critical virtual machines are protected by appropriate HA and DRS configurations, and that backups are validated, this approach demonstrates a commitment to business continuity and data protection. This aligns with general best practices for IT operations and, in a regulated environment, likely satisfy requirements for data resilience and service availability mandated by industry-specific regulations or general data protection laws. The focus on testing recovery procedures is crucial for validating the effectiveness of the DR plan and ensuring that the organization can indeed recover from a disruptive event. An incorrect approach that focuses solely on cost reduction by disabling HA for non-critical VMs without a thorough risk assessment fails to acknowledge the potential cascading impact of failures. While these VMs may not be deemed critical in isolation, their failure could still disrupt workflows or lead to data loss, potentially violating data retention policies or service-level agreements. This approach exhibits a lack of due diligence regarding business impact analysis and risk management. Another incorrect approach that involves reducing backup frequency for less critical VMs without considering recovery point objectives, RPO, is also professionally unacceptable. This decision could lead to significant data loss in the event of a failure, potentially violating regulatory requirements for data retention and recovery. It demonstrates a misunderstanding of the importance of RPOs in disaster recovery and data protection strategies. A third incorrect approach that involves consolidating multiple critical VMs onto fewer hosts to save on hardware costs, without ensuring sufficient resource headroom and failover capacity, is a direct violation of best practices for high availability. This configuration significantly increases the risk of widespread service disruption if a host fails, as there may not be enough resources on the remaining hosts to accommodate the workload. This demonstrates a failure to adequately plan for redundancy and resilience, which is a core tenet of robust IT infrastructure design. The professional reasoning process for similar situations should involve a comprehensive risk assessment that considers the business impact of potential failures for all applications, not just those explicitly labeled critical. This includes understanding RPOs and recovery time objectives, RTO, for each application, evaluating the cost-benefit of different HA and DR solutions, and regularly testing recovery procedures. Decisions should be data-driven, documented, and aligned with organizational policies and any applicable regulatory requirements. Question 16. Benchmark analysis indicates that a project team is under significant pressure to deploy a new vSphere 6 environment for critical business applications within an aggressive timeline. The team is considering skipping the detailed network configuration validation and the initial SC host hardening steps to accelerate the deployment, with the intention of addressing these later. Which approach best aligns with professional best practices for establishing a foundational vSphere 6 environment under such constraints? Option A. Focus on deploying the virtual machines first, Then configure the underlying vSphere 6 infrastructure components as time permits, assuming the applications will function adequately with a basic setup. Option B. Prioritize the core vSphere 6 deployment, including XC host installation and vCenter server setup, while creating a documented plan to address network configuration validation and host hardening immediately post-deployment. Option C. Expedite the deployment by using default configurations for all vSphere 6 components and skipping any form of pre-deployment testing or validation to meet the deadline. Option D. Proceed with a minimal configuration of XC hosts and vCenter server, focusing only on getting the virtual machines operational and deferring all advanced configuration and security measures indefinitely. The correct answer is B. Prioritize the core vSphere 6 deployment, including XC host installation and vCenter server setup, while creating a documented plan to address network configuration validation and host hardening immediately post-deployment. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid deployment needs and the foundational principles of robust vSphere 6 infrastructure. The pressure to deliver a functional environment quickly can lead to shortcuts that compromise long-term stability, security, and performance. Careful judgment is required to balance immediate business demands with the need for a well-architected and compliant virtual environment. The correct approach represents best professional practice because it prioritizes a structured, documented, and validated deployment process. This aligns with the foundational principles of IT infrastructure management, emphasizing planning, testing, and adherence to established best practices. In the context of vSphere 6 foundations, this means ensuring that core components like XC hosts, vCenter server, and networking are configured according to VMware's recommended guidelines and the organization's specific requirements. This proactive approach minimizes the risk of future issues, simplifies troubleshooting, and ensures the environment is scalable and maintainable. It also implicitly supports any relevant organizational policies or industry standards for IT deployment, even if not explicitly stated as regulatory in this exam context. An incorrect approach that bypasses initial planning and configuration validation for expediency is professionally unacceptable. This failure stems from a disregard for the fundamental steps necessary to build a reliable infrastructure. It creates technical debt, making the environment prone to instability, security vulnerabilities, and performance degradation. Such an approach violates the implicit professional obligation to deliver a quality product and could lead to significant operational disruptions and increased costs for remediation. It also fails to establish a baseline for future management and auditing, which is a cornerstone of responsible IT operations. Another incorrect approach that focuses solely on meeting the immediate functional requirement without considering scalability or future growth is also professionally deficient. While the system may work initially, it lacks foresight. This can lead to costly reconfigurations or complete overhauls as the organization's needs evolve, demonstrating a lack of strategic thinking and long-term planning. This approach neglects the principle of building for the future, which is a key aspect of professional IT infrastructure design. The professional reasoning framework that should be applied in such situations involves a systematic decision-making process. First, clearly define the project objectives and constraints. Second, identify potential risks and their impact. Third, evaluate different approaches against established best practices and organizational policies. Fourth, select the approach that offers the best balance of immediate needs, long-term viability, and risk mitigation. Finally, document the chosen approach and its rationale, and ensure thorough testing and validation before deployment. This structured approach ensures that decisions are informed, defensible, and contribute to the overall success and stability of the IT environment. Question 17. Strategic planning requires a proactive approach to managing potential issues within a virtualized environment. A vSphere 6 administrator encounters a recurring, minor performance anomaly in a specific virtual machine that is not impacting critical operations, but is noticeable. The administrator has a potential quick fix in mind that involves a non-standard configuration change, but is unsure of its long-term implications. What is the most professional and responsible course of action? Option A. Rely on advice from an online forum post that suggests a specific registry tweak to resolve similar issues, without verifying its applicability to the current vSphere 6 version or the specific VM configuration. Option B. Immediately apply the suspected quick fix to the virtual machine, as it is not currently causing significant disruption, and the administrator has a strong intuition about its effectiveness. Option C. Thoroughly research the anomaly using official VMware vSphere 6 documentation and community best practices to understand its root cause and potential solutions. Then implement a documented and tested remediation strategy. Option D. Ignore the anomaly for now, as it is minor and not affecting critical services, and focus on more pressing operational tasks. The correct answer is C. Thoroughly research the anomaly using official VMware vSphere 6 documentation and community best practices to understand its root cause and potential solutions. Then implement a documented and tested remediation strategy. Explanation. This scenario presents a professional challenge because it requires balancing immediate operational needs with long-term strategic goals, all while adhering to the foundational principles of vSphere 6, which are implicitly governed by best practices and vendor guidelines that form the de facto standard for operational integrity and security within the vSphere ecosystem. The core of the challenge lies in making a decision that appears to offer a quick fix, but could introduce technical debt or security vulnerabilities, impacting the overall stability and maintainability of the virtual infrastructure. Careful judgment is required to assess the true impact of each potential action beyond the immediate benefit. The correct approach represents best professional practice because it prioritizes a thorough understanding of the underlying issue and its potential ramifications before implementing a solution. This aligns with the principle of informed decision-making, ensuring that any changes are well documented, tested, and aligned with the intended architecture and security posture of the vSphere environment. By consulting official documentation and considering the broader implications, professionals uphold the integrity of the system and avoid introducing unforeseen problems. This methodical approach is crucial for maintaining a robust and reliable virtual infrastructure, which is a fundamental expectation for any IT professional working with vSphere. An incorrect approach that involves immediately applying a workaround without proper investigation fails to adhere to the principle of due diligence. This can lead to the introduction of undocumented configurations or security loopholes, violating the implicit expectation of maintaining a secure and stable environment. Another incorrect approach, such as ignoring the issue entirely, demonstrates a lack of proactive management and can result in the escalation of problems, potentially leading to service disruptions and data loss, which is a failure in professional responsibility. Implementing a solution based solely on anecdotal evidence or unverified sources, without cross-referencing official documentation, risks introducing incompatible configurations or unsupported practices, undermining the stability and supportability of the vSphere environment. Professionals should employ a decision-making framework that begins with clearly defining the problem, gathering all relevant information from authoritative sources, like VMware's official documentation for vSphere 6, evaluating potential solutions based on their impact on stability, security, and performance, and then selecting the most appropriate course of action with a clear understanding of its consequences. This framework emphasizes a systematic and evidence-based approach to problem solving. Question 18. Consider a scenario where a critical security patch for vSphere 6 X is released by VMware, addressing a known vulnerability that could expose sensitive virtual machine data. The IT operations team is under pressure to restore full system security immediately, but also faces strict service level agreements, SLAs, that penalize any unplanned downtime. What is the most professionally responsible course of action to ensure both security and operational continuity? Option A. Apply the patch only to a single, non-critical production host as a pilot, accepting the risk of potential disruption to that specific host while observing its impact on the wider environment. Option B. Immediately apply the patch to all production hosts after a brief review of the release notes, prioritizing the urgent security fix over potential but unconfirmed operational impacts. Option C. Delay the application of the patch indefinitely until a future major upgrade cycle, citing the risk of unplanned downtime and the potential for complex rollback procedures. Option D. Schedule the patch for application to a non-production vSphere environment that mirrors the production setup. Thoroughly test all critical virtual machine operations, and then plan a phased rollout to production during a scheduled maintenance window. The correct answer is B. Immediately apply the patch to all production hosts after a brief review of the release notes, prioritizing the urgent security fix over potential, but unconfirmed operational impacts. Explanation: this scenario presents a professional challenge because it requires balancing the immediate need for system availability with the long-term implications of security patching. The vSphere 6 Foundations exam, while not explicitly a regulatory exam in the traditional sense of financial services, operates within a framework of best practices and vendor guidelines that are implicitly expected for professional competence. In this context, the regulatory framework is the established and documented best practices for vSphere administration as defined by VMware and widely adopted by the industry. Failure to adhere to these best practices can lead to security vulnerabilities, system instability, and potential data loss, which are professionally unacceptable outcomes. The correct approach, which involves thorough testing in a non-production environment before applying patches to production, represents best professional practice because it directly aligns with the principle of minimizing risk. VMware's documentation and community consensus emphasize a phased rollout for critical updates. This approach ensures that potential compatibility issues or unforeseen bugs introduced by the patch are identified and resolved without impacting live services. This proactive stance is crucial for maintaining system integrity and user trust, which are core professional responsibilities. An incorrect approach that bypasses testing and applies patches directly to production environments is professionally unacceptable due to several failures. Firstly, it violates the principle of due diligence, as it fails to adequately assess the impact of the change. This can lead to unplanned downtime, data corruption, or security breaches, all of which are direct consequences of neglecting risk mitigation. Secondly, it demonstrates a lack of foresight and adherence to established IT change management processes, which are designed to prevent such disruptions. This disregard for established procedures can result in reputational damage and potential liability if business operations are significantly impacted. Another incorrect approach, which is to delay patching indefinitely due to fear of disruption, is also professionally unsound. While caution is warranted, complete avoidance of security updates leaves the environment vulnerable to known exploits. This inaction constitutes a failure to protect the organization's assets and data, which is a fundamental professional obligation. The regulatory framework here implies a responsibility to maintain a secure and stable environment, and prolonged neglect of security patches directly contravenes this. The professional reasoning process for such situations should involve a structured decision-making framework. This begins with understanding the criticality of the patch, e.g., security vulnerability vs. minor bug fix. Next, assess the potential impact of applying the patch versus the risk of not applying it. This involves consulting vendor release notes, community forums, and internal impact assessments. Following this, a risk mitigation strategy must be developed, which typically includes a testing phase in a representative non-production environment. If testing is successful, a planned, scheduled rollout to production with rollback procedures in place is the next step. If testing reveals issues, the decision to proceed, delay, or seek alternative solutions must be made based on the risk assessment. This iterative process of assessment, planning, execution, and review is essential for sound IT decision-making. Question 19. The investigation demonstrates that a proposed vSphere 6 upgrade to the production environment has been identified as potentially impacting critical business applications. Which of the following actions is the most appropriate first step to ensure a successful and minimally disruptive upgrade? Option A. Conduct a comprehensive impact assessment to identify all affected systems, dependencies, potential risks, and develop mitigation and rollback strategies. Option B. Immediately proceed with the upgrade, relying on the vendor's standard deployment guide to minimize time to deployment. Option C. Focus solely on validating the technical specifications of the new vSphere 6 features to ensure they meet performance benchmarks. Option D. Initiate the upgrade process and monitor system performance closely, addressing any issues as they arise. The correct answer is A. Conduct a comprehensive impact assessment to identify all affected systems, dependencies, potential risks, and develop mitigation and rollback strategies. Explanation. The investigation demonstrates a scenario where a proposed vSphere 6 upgrade introduces potential disruptions to critical business operations. The professional challenge lies in balancing the benefits of the upgrade, e.g., enhanced performance, new features, against the risks of downtime and data loss, especially within the context of a regulated environment where service continuity is paramount. Careful judgment is required to ensure that the upgrade process is managed in a way that minimizes impact and adheres to established best practices for change management and risk mitigation. The correct approach represents best professional practice because it prioritizes a thorough impact assessment before proceeding with the upgrade. This involves identifying all affected systems, understanding dependencies, quantifying potential risks, and developing comprehensive mitigation and rollback plans. This proactive stance aligns with the principles of responsible IT management and ensures that business continuity is maintained, a key consideration in any IT infrastructure change. While the 2V0-620 exam focuses on technical foundation, the underlying principle of understanding the implications of technical changes on the business is a core professional competency. An incorrect approach that skips a detailed impact assessment and proceeds directly with the upgrade would be professionally unacceptable. This failure to adequately plan and assess risks could lead to unforeseen service disruptions, data corruption, or extended downtime, directly impacting business operations. Such an oversight would represent a significant breach of professional duty to ensure system stability and reliability. Another incorrect approach, such as relying solely on vendor documentation without internal validation, is also professionally deficient. While vendor documentation is valuable, it cannot account for the unique configurations, interdependencies, and specific business requirements of an individual organization. Ignoring this internal context during an impact assessment creates a blind spot, increasing the likelihood of unexpected issues. A third incorrect approach, focusing only on the technical benefits of the upgrade without considering the operational impact, demonstrates a lack of holistic understanding. Professional IT practice demands a balanced view, weighing technical advantages against operational risks and business needs. Neglecting the operational impact is a failure to consider the broader implications of the proposed change. The professional reasoning framework for similar situations involves a structured approach to change management. This typically includes initiation planning, including impact assessment and risk analysis, execution, monitoring, and closure. Professionals should always advocate for a comprehensive impact assessment that considers technical, operational, and business aspects before implementing significant changes. This ensures that decisions are informed, risks are managed, and business continuity is preserved. Question 20. Upon reviewing a request to deploy a new set of virtual machines for a development team that requires specific network configurations and increased storage allocation, what is the most professional and risk-averse approach to ensure the stability and security of the existing vSphere 6 environment? Option A. Immediately proceed with the deployment as requested by the development team to facilitate their project timelines, assuming the existing infrastructure can handle the load. Option B. Prioritize the deployment of the new virtual machines and address any potential infrastructure issues or security concerns reactively as they are identified. Option C. Conduct a comprehensive impact assessment, including dependency analysis, resource utilization projections, security policy review, and a detailed rollback plan before approving and implementing the deployment. Option D. Deploy the virtual machines with default configurations and inform the development team that they will need to adjust their requirements post-deployment if issues arise. The correct answer is C. Conduct a comprehensive impact assessment, including dependency analysis, resource utilization projections, security policy review, and a detailed rollback plan before approving and implementing the deployment. Explanation. The scenario presents a common challenge in IT infrastructure management, balancing the need for rapid deployment of new services with the imperative to maintain system stability and security. The core professional challenge lies in the potential for unforeseen consequences of changes, which can impact service availability, data integrity, and compliance with established operational procedures. Careful judgment is required to ensure that the pursuit of innovation does not compromise the fundamental reliability and security of the vSphere environment. The correct approach represents best professional practice because it prioritizes a structured and controlled method for introducing changes. This involves a thorough impact assessment that considers all potential ramifications, including dependencies, resource utilization, security implications, and rollback strategies. This aligns with the principles of IT service management, ITSM frameworks, which emphasize change management to minimize disruption and risk. In the context of vSphere 6, this means understanding how new virtual machines or configurations interact with existing resources, network configurations, and storage, ensuring that performance is not degraded and that security policies remain effective. Adhering to established change control processes is also a key aspect of professional responsibility, ensuring accountability and auditability. An incorrect approach that bypasses or inadequately performs an impact assessment is professionally unacceptable due to several regulatory and ethical failures. Firstly, it demonstrates a disregard for the established operational procedures and risk management protocols, which are often implicitly or explicitly mandated by organizational policies and potentially by industry best practices that aim to ensure system integrity. Secondly, it introduces an unacceptable level of risk to the production environment, potentially leading to service outages, data loss, or security breaches. This failure to protect organizational assets and ensure service continuity can have significant financial and reputational consequences. Ethically, it represents a failure to act with due diligence and to uphold professional standards of care in managing critical IT infrastructure. Another incorrect approach that focuses solely on the immediate technical implementation without considering broader operational impacts, such as user experience or supportability, is also flawed. This narrow focus neglects the holistic nature of IT service delivery. Professionals must consider how changes affect end users and the support teams responsible for maintaining the environment. The professional decision-making process for similar situations should involve a systematic evaluation of any proposed change. This includes clearly defining the proposed change, identifying all stakeholders, conducting a comprehensive risk assessment, including technical, operational, and security risks, developing a detailed implementation plan with rollback procedures, obtaining necessary approvals through a formal change control process, executing the change during a planned maintenance window if possible, and performing post-implementation verification. This structured approach ensures that decisions are informed, risks are managed, and the overall stability and security of the vSphere environment are maintained.